in this problem, we're going to solve a ramp problem. So I start with the free body diagram. I know I have gravity. It's going straight down. I have tension force going up at the rope. I have the normal force, which is perpendicular to the ramp, or perpendicular to the surface. Now what I need to do here is I need to break down, I didn't do that very straight, I need to break gravity down into components, because we said going down the ramp, that's my x-axis, and then perpendicular to the ramp, that's my y-axis. So gravity is broken up into force of gravity in the y, and this is force of gravity in the x. Okay. So that's my free body diagram. From there, what is the value of tension? Well, we know how to solve any forces problem. Is be a kitten, be relaxed. Now the next thing I need to do is my F net statement. So tension is in the x, so I'm going to do F net in the x equals m a x. Now it says the object is at rest, so that means the acceleration is 0. So what forces are going down the ramp? Well, that is force of gravity in the x. Up the ramp is tension, and that equals 0. So tension equals force of gravity in the x. We talked about what makes you go down the ramp. That's the force of gravity in the x, which is mg sine of theta. And theta is this angle at the bottom of the ramp. Now, I can plug in my values. What does it give me for that? 20 for my mass. So then tension equals 20 kilograms times 10 meters per second squared times the sine of 30 degrees. With all of this, I'm going to end up with a tension of half of 200, so that is 100 newtons. Okay. The next problem, part C, says what is the acceleration down the ramp if the rope is cut? Well, back to the diagram. Okay. I had force of gravity going down. I have the normal force. I'm just going to leave tension out. Down this direction, this is force of gravity in the y. Here I have force of gravity in the x. So, by F net statement, okay, still in the x direction, the only thing is FGX. That's the only arrow in the x direction, and we said that is mg sine theta. So that is mg sine theta equals the mass times the acceleration in the x. Now we previously said mg sine theta was here, so I can just jump in and do that. That is 100 newtons equals the mass, which is 20 kilograms, times the acceleration. So here my acceleration equals 5 meters per second squared down the ramp. Okay. The last part, D, says how long will the block slide? Will it take for it to slide 5 meters down the rope when the rope is cut? Well, this one, it's implied that the velocity initial is 0. It started from rest. My change in x is the 5 meters. Then I also know my acceleration is 5 meters per second squared. The kinematic equation I would use here would be change in x equals v initial t plus 1/2 at squared. Plugging in my values. I would get, let's rewrite that one more time, change in x equals v initial t plus 1 half a squared. My v initial we said was 0. My change in x is 5 meters. My acceleration is 5 meters per second squared times time squared. Okay. Let's say this is going to be times 2 to both sides. So that's going to be 10 divided by 5. So that goes away. So time equals the square root of 2 seconds. Whatever number that is, but I believe you get the answer or the idea. Okay.